Dear students, this session we are going to continue Gauss divergence theorem problem. Okay, now consider second problem. Okay, verify Gauss divergence theorem for f vector equal to x square minus yz I vector plus y square minus zx j vector plus z square minus xy k vector over the rectangular parallelepiped bounded by x equal to 0, y equal to 0, z equal to 0 and x equal to a, y equal to b, z equal to c, right? So here x limit is 0 to a, y limit is 0 to b, z limit is 0 to c. Okay, now solution. So first write the Gauss divergence theorem statement. So what is the statement? Double integral over s f vector dot n cap ds is equal to triple integral over v del dot f vector dot dv, right? So we are going to prove LHS equal to RHS. Okay, first we are going to find RHS. What is RHS here? Triple integral over v del dot f vector dv. So, right, to find RHS, first we should know what is del dot f vector. Okay, what is given f vector? So this is given f vector. Okay, first write the given f vector equal to x square minus yz I vector plus y square minus zx j vector plus z square minus xy k vector. Okay, now find del dot f, that is divergence f vector. That is, first we differentiate I component with respect to x. What happened? X square become 2x, so this becomes 0. Don't put I vector. Okay, then differentiate this component with respect to y, become 2y, this becomes 0, right? Don't put j vector. Similarly, differentiate this with respect to z, become 2z, this becomes 0, therefore simply 2z. Okay, so what is del dot f vector this time? 2x plus 2y plus 2z. Okay, now apply del dot f vector here in this place, right? Therefore RHS equal to triple integral over v del dot f vector dv. Okay, so what is del dot f vector? 2x plus 2y plus 2z, taking 2 as constant, we have x plus y plus z inside the integration. So what is the dv? dv means volume, dx dy dz. V is parallelepiped, volume here is dx dy dz. Okay, first what is the limit of x here? 0 to a, y is 0 to b, z is 0 to c. Okay, as given in the problem, 0 to a, 0 to b, 0 to c, right? The limits are already given in the problem. So first integrate with respect to x. Okay, if we integrate with respect to x, x become x square by 2, but there is no x term here, so put x here, xy. There is no z term here, so put xz, because this is integration, this is not differentiation. Okay, if there is a constant term, we have to introduce the variable, right? Now apply limit. What happened? A square by 2 plus ay plus az. Right, now integrate with respect to y. Okay, what happened? So there is no y term here, so put y here. For integrating y, the y time this become y square by 2. There is no y term, so become ayz. Now apply limit b to 0. If you put b here, a square b, ab square by 2, ab z. Okay, now integrate with respect to z. Okay, there is no z term here, put z here, put z here, integrating z become z square by 2. Okay, now apply limit. What is the limit here? C, put z equal to c here, c here, c here. Also we have 1 by 2 in all the places. If we take 1 by 2 away and cancel with this 2, so we will have only 1 here. Okay, so what is the remaining term? A square b c plus a b square c plus a b c square. So this is RHS. Okay, now we are going to find LHS to prove this. Okay, LHS. So what is LHS here? LHS equal to double integral over s f vector dot n cap ds. So what is s here? S is the surface of the cube. Parallelepiped. S is the surface of the parallelepiped. So number of sides here is 6 sides. Okay, so separate 6 sides like this. Okay, we have to find the integral for every surface. S1, S2, S3, S4, S5, S6. So what is S1, S2, S3, S4, S5, S6? All are sides. S1 represent x equal to a, S2 represent x equal to 0, S3 y equal to b, y equal to 0, z equal to c, z equal to 0 likewise. Okay, so what about corresponding n cap unit vector? X equal to a, that means I direction, this is upper limit, so put plus I vector. X equal to 0, that is lower limit. Okay, x is there, so I direction, lower limit means minus j vector, minus I vector, sorry, minus I vector. Next one is y equal to b, that is upper limit, so put plus j vector because y is there, y is on j direction, so j vector. Okay, right. Next is y equal to 0, this is also on j direction but lower limit, so put minus j vector. Z equal to c is upper limit, so z is on k direction, so k vector plus k vector. Z equal to 0 is lower limit on k direction, put minus k. Okay, now ds, so x equal to a, right, leave x. What about remaining axis? Y z, put y z here. X equal to 0, leave x, that means leave x, y z, dy dz. Y equal to b, leave y. What about remaining axis? X z, put dx dz. Y equal to 0, what about remaining axis? X z, dx dz. Same thing here, z equal to c. What about remaining axis? X y. So similarly, same thing for z equal to 0, dx dy dx dy. Okay, next. Right now we are going to calculate for every surface integral over S1. So for this x equal to a, what is the equation of surface here? X equal to a, first equation is x equal to a, n cap equal to I vector, ds equal to dy dz. Okay, ds1 equal to dy dz and n cap equal to I vector. Put x equal to a in the f vector. Okay, if you put x equal to a here, a square minus yz I vector plus y square minus z a j vector plus z square minus ay k vector. Okay, right. Now double integral over s1 f vector dot n cap ds1, right? That means we need f vector dot n cap. Take dot product between these two. I dot I become 1. Okay, therefore a square minus yz. Put here a square minus yz. I dot j becomes 0, so becomes 0. I dot k becomes 0. So only one component is left here. Okay, what about limit for y? Y limit is 0 to b, z limit is 0 to c. So there is here dy is dz, that is ds1 equal to dy dz. It's already given here. Okay, right. Now integrate with respect to y first. Okay, therefore a square y minus y square by 2 into z. Then apply upper limit. Okay, we get this result. Then integrate with respect to z, become a square bz minus b square by 2 into z square by 2. Now apply upper limit c, right, become a square bc minus b square c square by 4. If you put lower limit becomes 0. Okay, now along s2, so this time equation of surface s2 is x equal to 0. What is ds2? ds2 equal to dy dz and n cap equal to minus I vector. Put x equal to 0 in the given f vector, we get this vector here. Right, now we have to find double integral over f vector dot n cap. That means take dot product between these two. I dot I become 1. Minus into minus become plus. Therefore y is at dy dz. Okay, because what is dy dz? ds2 is given here. ds2 equal to dy dz. All the data are taken from the table, this table. Okay, first we should construct this table properly. Right, now integrate this with respect to y square by 2, apply limit become b square by 2, then integrate with respect to z square by 2, applying limit b square c square by 4. Okay, similarly s3, this time y equal to b, ds3 equal to dx dz, n cap equal to j. Put y equal to b in the equation, become like this. Now find f vector dot n cap. What is n cap here? J. I dot j becomes 0, j dot j become 1. That means b square minus zx. Okay, so what is ds3? Dx dz. Integrate with respect to x, then integrate with respect to z. Okay, first integrate with respect to x become b square x minus x square by 2 z. And then applying limit, we get this. Then integrate with respect to z, we get this. After simplification, we get b square ac minus a square c square by 4. Similarly, along S4, y equal to 0, ds4 equal to dx dz, n cap equal to minus g. If you put y equal to 0, it reduces to like this. Okay. Now take dot product. I dot j becomes 0, j dot j become 1, minus into minus become plus, zx here. Now integrate with respect to x and z. After simplification, we get a square c square by 4. Okay. Now along S5. Right now equation of s5 is z equal to c, ds5 equal to dx dy, n cap equal to k vector. Now put z equal to c in the given vector f vector, become like this, right? Now find f vector dot n cap. If you find f vector dot n cap, what happen? I dot k becomes 0, k dot j becomes 0, k dot k become 1. So what is this? C square minus xy into dx dy. Integrate with respect to x, with respect to y, gives this result. Okay, so what is the double integral over sy c square ab minus a square b square by 4. Similarly s6, this time z equal to 0, ds6 equal to dx dy, and n cap equal to minus k vector. Put z equal to 0, f vector become like this. Okay, now we have to find f vector dot n cap. Take dot product between these two. I dot k becomes 0, j dot k becomes 0, k dot k become 1. Therefore we get minus into minus become plus xy. Now integrate with respect to x, become x square by 2x. Integration of x is x square by 2. Apply limit a square by 2. Integrating y square by 2. Applying b square by 2. Therefore after simplification, a square b square by 4. Right now for left hand side, we have to add all the results. Okay, put all the result like this. Okay, what happened? A square bc minus b square c square by 4 plus b square c square by 4, both are cancelled. Okay, b square ac minus a square c square by 4 plus a square c square by 4, now both are cancelled. C square ab minus a square b square by 4 plus a square b square by 4, both are cancelled. So remaining we have a square bc plus b square ac plus c square ab, which is our left hand right hand side. Okay, so right hand side result. Okay, now LHS equal to RHS, right? Hence Gauss divergence theorem is verified. Okay, thank you.